What up, everybody? My name is Nick Crecelius, and this is my cameraman. Hey. And I hope you are ready for some insane geometric fun, because this, ladies and gentlemen, is geometry in my bathroom.
Nice legs, Daisy Dukes, makes a man go. That's the way they all come through, like low cut, see through shirts that make ya. That's the way she come through, like. Cause I just set them up, just set them up, just set them up.
Alright, let's get started. Over here in the shower section, we have a geometric figure known as a cylinder. And a cylinder is a figure with bases that are formed by congruent circles in parallel planes. So this lovely object is a cylinder. And this angle looking thing is an obtuse angle, which is any angle with a measure over 90 degrees, and you can see it kind of like goes doot, doot, and that's over 90 degrees. And right here, on the dial, which is a circle, there is a diameter, which is a chord that passes through the center of a circle. And you see, here's the circle, that's the diameter. It passes through the center. And this is supplementary angles, which are two angles with a sum of 180 degrees. So this angle and then this angle, they're both 90, and they add up to be 180, which is a line. That's a line. And here we have vertical angles, which are two non-adjacent angles formed by two intersecting lines. So here's an angle, and then here's an angle, and they're vertical. Yeah. Here's a right angle, which is an angle with a measure of exactly 90 degrees. There, it's 90 degrees. And here is perpendicular lines. And those are lines that form right angles when they intersect. So here's a line, they intersect, and look at all these right angles that were formed. It's lovely. And, ooh, over here, on this big countertop thing, it could be described as a plane, which is a flat surface made up of several points. So you see it's flat, and it's got several points right there, and there, and there, and behind the shrubbery. Yeah. And on the plane, there's points, which are locations, usually represented by a dot. So this marble countertop thing is a plane, and then this Q-tip holder is a point in the plane. And then say this lovely mandarin grapefruit dial soap dispenser is also a point. These 2 points would be coplanar because they're on the same plane. Yeah, and let's see, this hair straightener forms an acute angle, which is an angle with a measure less than 90 degrees. So forms an angle, and that's less than 90 degrees. And let's see, these set of mirrors, they could be described as planes, and the two on the ends there, that one and that one, they could be described as parallel planes because they never intersect, and they're both planes. So yeah, that's a plane, that's a plane. And as you can see, there is no visible intersection. Right here on this lovely clock, we have a regular polygon, which is a polygon with all congruent angles and sides. So it's an octagon because there's 8 sides, I think. Yeah, 8. And they all appear to be congruent, and all the angles appear to be congruent, so it's a regular polygon. And there are several sets of skew lines in this diagram. For example, this board thing across it, say this line right here, it would be skewed to that line right here, like the one that goes across the floor, because skew lines are lines that do not intersect and are not coplanar. And as you can see, there is no intersection and they do not lie on the same plane, so they're skew lines. Okay, over here, it's just geometry galore, man. There's like geometry everywhere. You can say that this is a line segment, and also like that is a line segment. A line segment is a measurable part of a line that consists of 2 endpoints and all points between them. So if this is a line segment, over there is an endpoint, and over there is an endpoint. So that's a line segment. And right where the cabinet's like join or whatever, that would be considered the midpoint because it is the point halfway between the endpoints of the line segment. So it's halfway. And if this is a line segment also, and these shiny bracket things, they would be considered points. They would be collinear because they're 2 points that lie on the same line, or line segment. And the cabinet has a dilation on it because you can't really see because I can't back up anymore. But the internal rectangle right there, it is dilated up to the outside of the cabinet door thing. And the dilation is defined as a transformation determined by a center point and a scale factor. And I think that is all the geometry in my diagram. So, thanks for watching. I really hope you enjoyed. And have a great day, everybody. Keep a lookout for geometry in your world.